to help us with understanding correlations so that you can do your project. Okay? Remember, your project is your school district project. All this information is online. All about comparing school performance to demographics. Okay? So we're going to look at this linear regression. Okay? So you have learned how to find and write equations for lines of fit by hand. Okay, so we didn't really do it. We just skipped right to the calculator. So we are now going to do this on our calculator, and you will be able to use it for spreadsheets and stuff. Okay, so I am going to give you a list of numbers. And we are going to put it, and we're going to figure out how to do it in our spreadsheet. So we know from my whole little going through the with presentation, the PowerPoint. Okay, if the correlation coefficient is close to 1 or negative 1, the fit is what? Strong. If it is far away from 1 or negative 1, the blank is weaker. The fit is weaker. Okay? The scatter plot is random, then there is no correlation, right? If the correlation coefficient is positive, the slope is doing what? It's positive or it's increasing. And if it's negative, the slope is decreasing. Okay? We often need to insert the slope and y-intercept in the concepts of problems. Slope can often follow this pattern. It's the topic of data. It increases and decreases. It's the slope, y units per x units. The y-intercept is the starting value, or what the dependent variable is when the independent variable is 0. Okay? So, let's look at this example. The average lifespan of American women have been tracked, and the model for the data is y equals 0.2 times time plus 73, where T0 corresponds to 1960. So what does this mean? If we're going to interpret this, what does this mean?
So, T is however many years after 1960.
Yes. So do you think, what do we think women's lifespans are doing? Are they going down or up or what? Okay, so we're saying that the lifespans increase of women increase by 0.2 every year. Okay? And the starting value is 73 years in 1960. So that means somebody in 1980, the average lifespan, they live longer than somebody in 1960, right? So we're saying that the average lifespan in 1960 was 73, and that each year it increases by 0.2. Okay? All right. Now we've got this data right here, and we are going to put it into our calculator. And there's kind of some instructions in the front, and I've kind of gone over some too. But instead of typing in 2000, 2001, 2002, 2003, 4, 5, 6, 7, 8, and 9, we're going to type it in as 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, I'm going to try to show what my calculator looks like underneath this screen so that it will record a little bit better. So tell me if you guys are having trouble seeing this. Okay, so the first thing you're going to do is you're going to go to a list in spreadsheets, right? That's that green button. Okay, and it comes comes up like this. I'm going to go up to where it says A at the very top, and the first thing I'm going to type is year. Y-E-A-R. And then under B, I'm going to put income. And we know it's in billions. I'm not going to put that on here, but we know. I know it's in alphabetical order, so it's a little bit struggle to type it in, but we can do it. Okay? And then I'm going to move right down to 1 under year, and I'm going to put 0 to 8. So I'm going to hit 0, enter, 1, enter, 2, enter. Does that make sense? 3, enter, 4, enter, 5, enter, 6, enter, 7, enter, 8, enter, and 9, enter. Pretty straightforward? Okay, and then under income, under next to 0, I'm going to put 7.48. Next to 1, I'm going to put 8.13. Next to 2, 9.19. Next to 3, 9.35. Next to 4, 9.27. Next to 5, 8.95. Next to 6, 9.25. Next to 7, 9.65. Oops. I'm going to fix that. 9.65. Next to 8, 9.85. And finally, next to 9, 10.21. Okay. So I've got all this entered. Now, I'm going to go over to column C, right under the gray area. You guys kind of see that? And I'm going to hit menu, and then I'm going to hit number 4, which is stats. And then I'm going to hit stats calculations. And then I'm going to pick linear regression, y equals mx plus b. You can do linear regression a plus bx just as long as you remember that's what the equation looks like. Okay, I can go back, yeah. So I'm in a blank square next to it, right? Because if you're on one of the squares on top of it, it's not going to work. Blank square next to it, I hit menu, stats, statistics, stats calculations, and I'm going to go down to linear regression. I like number 3. Now for the X list, I'm going to put what I wrote in, which was year. Under Y list, I'm going to put income. Okay, and then I'm going to hit OK. And all this stuff comes up. Yeah.
I'm getting a syntax error very not defined.
Can you bring it up?
Spell it.
Yeah. Okay. All right. So we need to be in a white space, and then we hit menu, statistics, stats, calculations. I'm going to pick number 3, y equals mx plus b. And then we're going to pick year, Y-E-A-R. We're going to pick income, and we're going to hit OK. So hers is coming up funky. So I think part of the problem is she's got stuff here and here. So it doesn't know which one to choose from. So under here, we're going to delete that. We'll delete that. And then go 1.3. Right, because you just opened it and opened a saved document, an unsaved document, but it already had stuff in it. And since it already did and you just added a new one, it didn't know what to do because they were both labeled the same thing. So unfortunately, I think what you have to do is exit out and type it all in again. Open up a brand new document. Sorry about that. Okay. So the first thing is we should be able to see our line of best fit, which if we look, it tells us that it's using y equals mx plus b right here. And then under that it tells us what our m is. So we can say y equals 0.23206. And then it tells us our b is, that's x, plus our b, which is 8.088. Okay? And then we can go down and we can see our r is 0.87551. Okay, now that we have this information, I say let's create a new page. R is your coefficient correlation. It's 0.87551. I'm going to look at what this fit looks like. So I'm going to create a new page. Go down to number 5, add data and statistics. Make sure you label the bottom year.
Control doc.
Yep, and income. And then I want menu, analyze, regression, linear. I'm going to choose y equals mx plus b. And it's the same thing. So I need to do that way slower, right?
Yeah.
Okay, so I hit menu. I'm going to click analyze, number 4. And then I'm going to hit regression, number 6. And then it should be like number 1. Yeah, I'm going to do it all again. Okay? So I'm here, right? I've labeled my stuff. I've got the points. Everybody's got it like this who's trying to do this, right? Okay.
But how'd you do that again?
I-
Get to there.
I went and clicked. How did I? Okay. So I'm right here.
Yeah.
Okay. I hit Control Doc, and it was adding a page. I go down to number 5, add data and statistics. I click on the bottom year. I go over and click the side, and I put income. Okay. Now I am going to hit menu, analyze, number 4, regression, and I'm going to hit number 1, show linear regression, y equals mx plus b. Okay. So what do you guys think of the fit? Is it a good fit or a bad fit? What is the correlation coefficient? Is that close to 1? Is 0.8755 close to 1?
Yeah.
So I would say it was a strong fit. And then, yeah, by how close it is to 1 or negative 1. And then you don't, but I wanted to show you. And then interpreting the slope, it's as we get 0.23 approximately. So as the year increases, as the years increase, the income increases. Each year. And what about 8.088 being my y-intercept?
That's the average.
That's where we start. Okay. One more, because I think this is really important. We want to look at where 2013 would be.
I have a question.
Yeah.
That's where we started. How come 2000 is?
Right, because it's not quite right, right?
Yeah.
Because remember, it's fitting it for all those random pieces. So if I look at my line, see, this is where I actually started, and this is where my line of best fit started.
So it's just waiting for the line.
Shh, please listen, guys. Okay, so if I was looking at 2013, I'm literally, quiet please, I'm literally taking this, y equals 0.23206, and plugging in 13, plus 8.088. But where is it actually going to be? Might be different than where it ends up being. Okay? So I'm going to stop there. This is just an example of how to start doing this. Tomorrow I want you to have that sheet filled out. Who's in your group? And your hypothesis. Tomorrow, excuse me, I'm still speaking. Excuse me, I'm still speaking. Tomorrow we're going to come in and we're going to get computers right away. Okay? There hopefully will be on your desk left over from second hour, but if not, you'll need to get them. You'll turn in that paper to me and you'll get started on doing your research and making your scatter plot and finding your line of best fit. Okay? What, Maya? Only 2.